Hello everyone. This question has been taken from Olympiad Pathfinder, multiple choice question number 19, chapter 2. The question says, in the setup zone, this is the setup. The pulleys, the cords and the spring are ideal. It means the pulley, cords and the springs are massless. Okay. And pulley is frictionless as well. And masses of the loads are indicated in the figure. Okay, that's fine. Initially, the system is in equilibrium. In this condition, in the diagram which is shown is in equilibrium. What should be the range of mass m, capital M? So that acceleration of the load of mass 2m, this is your 2m mass, becomes greater than acceleration of free fall immediately after the cord is cut at P. This is the P point. So let us discuss this problem. System is in equilibrium. Okay. This is one thread. Second thread is this. Third thread is this. All these threads are massless. No mass. Okay. Due to this capital mass, gravitational force acting on it will cause the tension in this thread. So that tension force we have taken as T1. Since it is a massless thread, so tension at all the places, all the points in the thread will be same. So T1 here, so T1 will be here as well. In pulley 2, if you see this thread, the second thread we have taken the tension as T2. It is again a massless thread. So at all points in the thread, the tension will be T2. Okay. The third thread, this one, we have taken the tension as 3, tension force as 3, T3, sorry, T3. So again the tension at every point in the thread, wherever we take, the tension will be T3, right? So we will make the free body diagram of block of mass M, this one. So this is your free body diagram. Okay. One more thing to discuss on it. See, when this load was applied, this thread came into tension, due to which it has pulled this pulley up. Okay. Until the time it came in equilibrium. Okay. So when this pulley went up, thread is inextensible as it is an ideal thread. So what will extend? Extension will be in the spring. So original length of the spring was L, capital L. Now we have assumed that Y is the extension in the thread due to this load, when the load was applied, right? Okay. Now we should switch on to free body diagram of block of mass M. So this is the free body diagram, right? Which all forces are acting on it? The tension force T1, upward direction. Capital M into G is the weight of this. There is no acceleration since the system is in equilibrium and this mass is also in equilibrium, so no acceleration. So mg will be equal to T1, equation 1, right? Now we will make the free body diagram of pulley 2, which we've shown here. On pulley 2, if you see this tension force, T1 will act in the upward direction, okay? And T2 will act here due to thread number 2 and here also. This pulley is also in equilibrium, as in the question it is given, the whole system is in equilibrium. So it means downward force will be upward force, right? So 2T2 will be equal to 2T1. And that is equal to mg from equation 1. So we have used that. So tension 2, the T2 has become capital M into G divided by 2. So this we have named as equation number 2. Let us go on FBD of block of mass 2m from the previous page. It was attached to thread 2 on the top side. So T2 will come here, T2 will act here on this block. Okay. And also attached at the bottom with the thread number 3. So T3 has come here. Okay. Which is acting downward. And weight of it will be acting downward, that is 2 mg. This also does not have any acceleration. So downward force will be equal to the upward force, right? So T3 plus 2 mg is equal to T2, which is equal to mg by 2. Okay, so T3 will be equal to capital mg by 2 minus 2 mg. And let us say this equation as number 3. Now we go for free body diagram of block mass m when it was in equilibrium, this mass. Which all forces are acting on it is Ky, the spring force on the top of it, right? This is connected at the bottom with the thread 3. So T3 will act here in the downward direction. And this is the weight which is acting downward, small m into g. Okay. Since it is in equilibrium, so again upward force is equal to downward force. So K into Y, that is spring force, is equal to T3 plus mg. T3 we can replace from equation 3. Capital M into G divided by 2 minus 2 mg. And this again plus mg. So Ky ultimately will become capital M into G divided by 2 and then minus small mg. So this is equation number 4, right? In the question it is given now this when the system was in equilibrium and thread number 2 has been snapped off or cut from point P. So what will happen? When the thread is cut from here, so T2 will immediately become 0. Okay. And T3 will change. Correct? So T3 will change just after the thread is cut due to infinitesimal displacement in the thread in infinitesimally small time, right? So now let us say the tension has become T, which is shown here after cutting the thread from P point. In this whole scenario, what is happening when you are cutting this thread? This block will start going down, right? And spring force is acting on, and this block is attached to there's a small M block, right? spring force is acting here in the upward direction. So spring force will not change. Why? Because the extension in the spring still is y. So ky will remain same. Okay. So what is happening? Your ky is remaining same. Your T3 has come down. T3 has come down. The value of T3 has gone down just after cutting the thread at P. Okay. So T plus mg will be lesser than ky, right? Due to which an unbalanced force will come up on this mass, and this will set the acceleration a in this. Let us say that acceleration a in this. And since at the other end this thread is attached to 2m, with the same acceleration it will pull the mass 2m downwards, right? So we will use that concept. This concept is very important to understand. Okay. So now we will make free body diagram of mass 2m just after the thread cut at P. So from NLM, that is Newton's law of motion, 2mg plus T, 2mg plus T is equal to mass into acceleration. Mass is 2m into acceleration. It is coming downward, right? And this is equation number 5. Free body diagram of mass m attached to a spring just after the thread cut from P is this, right? This is going up with the acceleration a. Okay. Ky is the spring force in the upward direction. T is the tension force due to cord number 3, which is connecting this m with the 2m, right? And mg is the weight which is acting downward. So from Newton's law of motion, we can write this equation: ky minus T minus mg. This is the unbalanced force. So this will be equal to ma. See, unbalanced force basically is the resultant force, the net force. So don't get confused that any unbalanced force. We are saying it is as unbalanced force because initially the system was in equilibrium. So now the equilibrium has been disturbed. Because of that, the unbalanced force has come up and this block has accelerated with a acceleration in the upward direction. This equation we said as number 6. So adding equation number 5 and 6, ky minus T minus mg is the 6. 2mg plus T is equal to ma was number 5 equation. So we have added this. So ky minus T minus mg plus 2mg plus T is equal to ma plus 2ma, right? So T and T will cancel out, right? And this expression will become k into y plus small m into g is equal to 3ma. Okay. Now you might be thinking, why should we add these 5 and 6? Because we just want to cancel out t so that we don't have to work on equations to equate t and then putting the value. So t is just cancelling out here. Okay, so that is the reason we have added these two equations. So this expression we got ky plus mg is equal to 3ma, right? Now from the equation number 4, we will put the value of ky because ky is the only force which is not changing just after cutting the thread at P. Okay, so ky will remain same as it was before. So ky is mg by 2, capital Mg by 2 minus mg, and this is your plus mg is equal to 3ma. This is mg, 3m we will bring this side, so this will become 6m is equal to a. So after calculation, you will get that m. Now a Now in the question it is given that A should be greater than G. So we will use that. So right side, so we can write this equation should be greater than G. Okay. And hence M will be greater than 6M. So in the option, if you see, the option B is saying that M should be greater than 6M. Okay, capital M should be greater than 6 small m. Okay, so that option B will be the correct option. Hopefully the concept behind solving it is crystal clear to you guys. In case any issue in understanding at any point, please write in the comment box. I will explain. I will take your doubt and explain it. Thank you.